20 of GE103. So today we'll try to complete the chapter of pointer. So whatever information, whatever the concept remain from this chapter, today we'll complete it. So if we see the chapter, I think only three important concept left from this chapter. So let us complete this three important concept today. First point is called array of pointer. So what is called array of pointer? This is very easy. Um, to understand this array, suppose we have some variables like integer a, b, c, d. We can write multiple variables like this. Instead of storing all these variables, we can also use a array like this, like and I've already explained you the advantage of using array instead of variable when you need a set of values, right? That is clear. So in that case, if I write x0, maybe I can also write x0 equal to a, or I can write x1 equal to b. That is also possible, right? You can assign the each element of this array to the value of some other variables. So that is perfectly fine. That I think there is no issue in this code to understand. So now instead of this, if I say these variables integer star a, star b, star c, star d, what are this? These are also variables, right? These are variables, but they are pointer variables and they have some specific task to do. What is called pointer variable, I have explained it many times, so I'm not explaining it again in this lecture. These are pointer variables. So if these are pointer variables, then it may be possible that we can store this variable instead of writing the separate variables. We can also store all this pointer in an array, right? Because here there are multiple variables, integer a, b, c. So what we have decided that okay, we'll not go for multiple integer variable. Instead of this, we'll go for a single array of integer, and also we can store all these variable there. So in the same way, if I want, instead of if we want, if we have if some in some case we need to deal with multiple integer pointers, and then instead of storing them in separate variables, maybe we can just store use a list of that means maybe we can just use a array of integers. So maybe we can use like x10. What is this actually? This is called a array of pointers. This is not a pointer to an array. So when we write in this, so always remember this syntax. The syntax may confuse you sometimes. So if we write star here and then we write declare like an array like x1, then don't think that x is a pointer. It means that this x is an array. X is an array, okay, but each element of this array is an integer pointer. So x0 is an integer pointer, x1 is an integer pointer, like this. So what can you store in x0 and x1? You can store in x0 an address of an integer variable. You can store in x1 an address of an integer variable. Why? Because each of this element in this array is an integer pointer. I hope this is clear. If this part is clear, then the array of pointer concept is clear. Okay, I mean that's why I'm again repeating this. If I write this, then it's an array of pointer. It means that each element of this array is a pointer of integer. Pointer of is a integer pointer. Okay, so in that case, suppose here uh, what is a? A is the integer pointer, so I can write x0 equal to a. What is b? B is the integer pointer, so I can write b here. Okay, why actually what a is storing? A is also storing a address of another integer variable, right? Instead of writing this, I can also write, for example, suppose this line is not here. Instead of this, if I have two variables like a, b, c here, three variables. So in that case, I can also store means address of a here and address of b here. That is also fine. Why this is fine? Because if we go for integer star p, then I can write p equal to address of a, right? This type of lines we have already written in our previous pointer programs. It means that p is a pointer which can store a address of integer variable, and here in this line I'm storing the address of a, which is an integer variable, in p. So if this is true, if these two lines is possible, then this same thing is possible here, because x is an array of pointer. So each element in x is an integer pointer. So in x0 I can store address of a, in x1 I can store address of b. That is fine. Okay, so this is called array of pointers. And Using array of pointers, you can also represent the array, means array of strings. For example, suppose if we have a string here, suppose character star p1 is string 1. In last class I've explained you that you can write declare a string or in this format, right? So now what I'll do, I'll declare a few more string like this. This is string 2, and then maybe character star p3, then string 3. Okay, and maybe there are some more I'm not typing. So instead of writing all these characters separately like p1, p2, p3, if we want to store them in a 2D array, 2D, not just exactly a 2D array, but if we want to store it as an array of string, means this is one string, this is a second string, this is third string. If we want to store them as an array of string, then it is possible if we use the array of pointers. How? So if I use a array of pointer like this, star, then strings strings, and this suppose I'm writing here 3. So what is this? This strings is an array of string, and so strings is an array of pointer. So there are 3 pointers possible. Each pointer can store one string, one base address of each string. So what I can write here, strings strings 0 equal to p1. I can write this. I think it is fine if I write this. I can write string 1 equal to p2, and I can also write strings 2 equal to p3. Can I write this? Yes, I can write, because this is array of pointers, and I can point the string 0 will point this, p1 is stored here, p2 is stored here, and p3 is stored here. So if you want to access this string 1, you can use string 0. String 0, if you use string 0, then you can access this pointer, this string. Okay. And if instead of separately assigning it here, you can also assign directly means you can also write string 0 equal to, you can directly write here string 1, and the same, in same manner you can also write it here string 2, and you can write here string 3. this is also this is also correct, because if this is correct, because then this one is also correct. So instead of writing this, if you remember when we have studied two-dimensional array, there is a way to initialize the arrays also. So if you see this example is that they're declaring an pointer of array, and then initializing the array also. So initializing means there are 3 elements here. Actually it's an array, so there are 3 elements. So whatever we have written, they have done the same thing, but then initializing it during at the same time. So what they did, the string 1, suppose this is string 1, the string 1 is assigned to name 0, Australia is assigned to name 1, and India is assigned to name 2. There should be in this, there will be some error here. So this invert is quotation is missing here. Okay. So now I'm not writing any specific program for this array of pointers, but what I'm advising you that read this book, and there are some example program in this. You can study this, or on top of that you can search internet and maybe go to geeks4geeks.com and try to find out some examples on array of pointers, and try to resolve them. Then in this way you will, this concept of array of pointer will be clear to you. Okay, this part is done. Then I think in last class I have covered this part, functions that return multiple values. It's actually talking about call by reference. So I told you to go back to my previous lecture where I have explained you call by value and call by reference, and then you read this part. So this is still an assignment. I'm not explaining it here because I've already explained it. At that time I have not just only thing I have not explained was why I am using star, why I'm using address of thing. So now when you will read it, you will understand. So I'm not explaining it yet, but yes, this is the point, that if you want to return multiple values from a function, then use call by reference concept. Okay. Then pointer to a function argument, pointer as a function argument. That part is also you study, because if you understand call by reference, then you will also understand this pointer as a function argument. Okay, so next point is function returning pointers. So till now what happened, that most of the code that I have written, its function is that is a function, and function is returning a value, either maybe it's a integer value. In last class, I have written a function called integer sum, then that function is returning an integer value, right? After adding these two parameters, it will return the integer value. Sometime it can return another data type also. But is it possible that function will return a pointer? Because pointer is also a data type, right? Integer star v is a is a pointer to integer variables. So it is possible that a function can return a pointer. Yes, it is possible, and see how the syntax should be written at that time. So in that case, suppose if we write this function integer star larger integer star, then what does this mean? It means that this function, this particular function, accept two call by reference parameter, means it will take two pointer as a parameter, integer star, okay, and it's also returning integer pointer. So if you see the code here, uh, or maybe I can write this code for you. Let me quickly run only one code for you to explain what is how to return a function, means pointer from a function. So I'm deleting all this thing from here. Let me first write a function here, integer star, then maybe sum, or maybe max, which one is maximum, and integers star a, integers star b, and then if star a is greater than star b, return a, else return b, else return b, else return b. Okay, and there should be a function prototype here. Okay, so integer star, then max, then integer star, then integer star. Okay, and just here I'll use two variables. Suppose integer x equal to 10, integer y equal to 30, and then let me call integer star p equal to max x comma y. It should be address of x and address of y. Okay, and then if I want to print the max, I have to write here printf the max value is percent %d, and what I need to write here is star p. Okay, so let me run this code. So it should print maximum value is 30, so it is printing 30. So just quickly try to understand the code. It has a few additional concept also. What are the additional concept? First of all, you can see this function, if we ignore this part also, this integer star p, what it is returning, ignore the return part of that function. If you ignore the return part, then you can see that this particular function is calling this parameter as call by reference, not as call by value. See here, I am passing address of x, address of y, and I'm if you pass the address of x, then according to call by reference, you have to store it in a pointer. That's why I'm using a pointer a, integer type pointer, and integer type pointer b. So this address of x will store in a, this address of y will be stored in b. Now inside this, since a and b are pointers, so if you just use a, if you use a, it means at value stored in this pointer, so it's an address. What is the value of a? Value of a is address of x, right? And if I write b, then it's b means, just if you write b, then it means address of y. But here what I want to compare, do I need to compare the address of a and address of x and address of y? No, I don't want to compare address of x and address of y. I want to compare the content of x and content of y here. So if I want to access the content, then you have to use star a. I hope this part is clear from the last few lectures of pointer. That's why I'm comparing here. If star a greater than star b, if star is greater than star b, then return the point a. So the moment you are returning a, you are not returning the value of means value of x. You are returning the value address of x. Why? Because a stored the address of x. That's why I'm returning, and a is a pointer. That's why when I'm returning a or either returning b, so both a and b are not simple variable, they are pointer variable, integer pointer. So that's why I have to mention here integer star. Integer star means this function return a pointer. And see here the function calling. In function calling, I'm calling this function, but when the value returns, it returns a pointer. So that pointer must be stored in a pointer variable. So I'm storing it in p. And now if I want to print the maximum value, it is printing star p like this. So ultimately, if you see here what actually p is storing at line number 7 after calling the returning from the function, after returning from the function, p is actually storing the address of y, nothing else. It is because if you just cross check everything what this max is doing, and ultimately after returning from max function at line number 7, the p is storing the address of y. So address of y is actually the value of y is 30. So if you write star p, then it will print the value of y, which is 30. I hope it is clear that how you can return a pointer. Only thing you have to understand is you cannot, if you try to do it like this, that no sir, I will pass call by value. I'll pass call by value. And what I will do here, this A and B are call by value, no problem. Okay. I will use a pointer here like this, integer P, integer star P. Okay. And then maybe I'll use another variable called max, and I'll write here that max equal to a, and in this case I'll write max equal to b, and after this here, after coming from if, I'll return p. uh, do you think this is correct? One more line is required, so I'll write here p is address of max. If I write this, then also it looks correct, right? What I am doing here, that I am calling a max function, and inside the max I'm calling this value x will be copied here, y will be copied here as a call by value. Now I'm using a pointer here, I'm using a local variable, and now p is pointing this local variable. So actually p is storing the address of max, and now I'm comparing if a is greater than b, then max is a, and if a is less than b, then maximum is b. And ultimately, so after this line, after before start means if I say here at line number 20, the max will store the maximum value, max variable, and the address of max is stored in p. So if I return the pointer p, then also it should correct, right? It should correct, because here I'm returning the address of max, returning the address of max, which is storing the maximum value. But why it will not work, I'm sure it will show a error. It is not showing error, but yeah, it's not correct actually. uh, it is not showing a error here, but it's not a correct way. Why it's not a correct way? Because there are many there may be chance that this will not give you correct result. Why it is giving you correct result here, I'll also explain. See what is happening here. This max is a local variable, right? It's a local variable. So the scope of this variable will be and after returning from this function. So the moment you are returning from this function, you are going here, this variable max is actually it's died, it's dead. But that I have explained you when I have explained you the scope of a function, right? The scope of a variable. But I said that if it's a local variable, the moment you come out from this variable, then that variable is dead. But that, what that means, the term that doesn't mean that the moment you come out from this, it's the value will be deleted. Value will not be deleted. Value will be there. Value will be there until some this particular memory will be required by some other operations. So suppose if you return from this here, from you come out from this function, then there is a memory allocated for max. Immediately, if this particular memory is required for some other variable, then it will override. Otherwise, for some time, maybe that memory will be there. That's why the same thing happening here. What you have done here, you have defined a local variable max, and this max address is known by the pointer p. And after returning from this function, the max is now it's not required, and its scope is already over. So it should be removed, but as I said, it it may not be immediately removed. Remove only occurs when if some other variable or some other other purpose, some another location will be used by the another variable will use that particular location that is given to max, but that may not be required immediately just after coming out from this function. The same thing is happening here. So max is a local variable and the address is known to p, and I am returning the address of p here, and now here I can access it, but it may not be true for every time, because sometime what will happen that this particular address variable, it is assigned to someone else, so it will give a wrong answer. So the conclusion that I am giving you, never return a pointer to a local variable from a function. This is not good, and sometimes it may show you null pointer exception also. Sorry, segmentation false also. So never return a pointer of a local variable. This is not the correct way. Okay, so I think the details of the point that I am saying, it's also written here. Note that the address return must be the address of a variable in the calling function. It is an error to return a pointer to a local variable in the call function, but sometimes it depends on compiler. So this particular compiler is not giving errors, though I am returning a pointer to a local variable max, but it is not showing error. But according to this book, it should show error. So it's depend on compiler, but whatever compiler you are using, my advice is not to use it. Okay, the next point is called pointer to function. Pointer to function means whatever pointer that we have discussed till in this class are pointer to a particular variable type, either it is an integer, float, or character or something. But is it possible to create a pointer to a function? Yes, it's also possible. So it means that we can also create a pointer variable which can point to a particular function, not a particular variable. Okay, and that is the syntax should be written in this format. This is if we write this, then this is called pointer to a function. Don't be confused, because if I write this integer star sum integer comma integer, then this is not a this is a function. Sum is a function here which is returning pointer. But if I write integer star sum integer integer, if I write this, then this in second case sum is a pointer to function. So this bracket has lot of meaning here, so always understand, remember this. What if I write this, that I have written a program for this, right? If I write this, it means that sum is a function which has two parameter, integer parameter, and it is returning a pointer to integer, right? Integer pointer. But in this case, if you use bracket here, then it means that it's not a function. Sum is not a function. Sum is a pointer to a function of type. Sum is a pointer to a function that accepts two integer parameter and returns a integer variable. Okay, so sum actually, this is a pointer which what kind of function it can point? It can point this type of function. Suppose whatever with the name here, xxx and integer, this type of function it can point. So let me write a code for you, then it will maybe I'll delete all this thing here. Let me write two functions, simple function here. Okay, and maybe return value. All this thing is not required. I'll directly return a plus b. This is for sum. This is sum. Okay, and then let me write another function which is called multiplication. Multiplication mul s star b, and let me write the prototype also. Integer sum integer comma integer. Okay, and then copy this line and write for multiplication. So we have two functions here. And we can easily call them from directly from here, right? So I'll not create the printf. The value is not maximum. The value is %d, and it will store in p, suppose. And here let me call sum. What will be the output is 40. I think I no need to explain this code. If you need some time to understand this code, you can just pause this video and try to understand this code. There is nothing new in this code, you know this. So whatever addition new, that will be added now. So what I'll do here, I'll use a pointer. What type of pointer I'll use? Integer star function fnc. It's a pointer. Okay, it's a pointer. So fnc is a function, is not a function, it's a pointer to a function. Now this pointer can point which type of function. This pointer can point this type of function where the function which has two integer arguments parameters and return an integer value. So that's why it is written like this. So this fnc is a pointer to a function that accept two integer parameter and return an integer. So it can point this type of function. So here if there is another function, suppose like this, character get data in integer, then you cannot, this particular function cannot point this pointer cannot point this function, because this function is taking only one parameter as integer parameter and returning character. So you have to remember this. Now here if I write f and c equal to sum, and now here if I call f and c, then what it will print, sorry, um, f and c equal to sum, we need to store this return variable in p, right? P equal to this, what will be the result? See, it is printing 40, right? It is printing 40. So now what I will do, I'll not change anything here, only I'll change something in 11. What I'll do here, instead of sum, I'll write here multiplication. And now see the change. Now it is printing 40. Let me now run it. Now it is printing 300. So why it is printing 300? Because now at this moment line number 12 is calling for multiplication. So you can see the same line number 12. I'm not changing anything in line number 12, but first it was calling the add sum function and it was adding x and y and result was 40. But the same line number 12 is now calling multiplication function and now it is multiplying x and y. How that's possible? Because f and c that I have written here, it's actually not a function. I'm not calling a function, it's actually a function pointer. So it depends when I'm calling this a function from this pointer. The important thing I have to check that currently which particular function it is pointing. So check at line number 11, this particular pointer is now pointing multiplication function. That's why it is calling multiplication. If I write here sum, and now if I come here at line number 12, then before calling this function, this is a pointer, fnc is a pointer, so it will check that this pointer is pointing which function now. So it is pointing sum, so it will call the sum function and result will be again 40. See, 40. So that's the purpose of what we can say pointer to a function. And as if you see the book, in book it is written that you have to call function like this. I think both will be correct. If you run it, then also it is correct. But it's not always necessary. You can also run it like this. Okay, so the purpose of a pointer function is one purpose is if you have multiple functions and you want to call them without knowing that how different time you need to call different functions, then you can use a pointer function, and based on some logic, whenever requirement, you can assign a particular address of a particular function to that pointer, and you can use this pointer, and it will call my different value different functions. If you want to know more about pointer to a function, then just type this in Google, pointer to function. You'll get lot of examples. So our best site is called Gigs for Gigs. So there is some pages already there in Gigs for explaining pointer to function. I think pointer to function is clear to you now. But what is the actual use? What is the benefit of using pointer to function? That I am not explaining properly, but you can study it from internet. And again, this is an assignment for you. You try to find out what are the scenario when a pointer to a function concept will be helpful as a programmer. Okay, so I think all this important part of this chapter is done. Okay, so only thing remains, I think, is pointer and structure. Okay, let me finish this so quickly. There is nothing new here. You know what is called structure. You know how to declare a variable in structure. You know what is called array of structure. Only thing that I have not defined is, suppose you have a structure inventory, that struct structure inventory a. If I write like this, then a is a variable of type structure inventory, right? Instead of this, if I write star a, what is this? A is a pointer, right? Now a is a pointer which can store the address of a structure variable. So let me copy this line here. Home, and suppose this is a variable xy, or you can say structure one. S1 is a variable and a is a pointer. So here I can write a is address of s1. What does it mean? That a is a pointer. A is just a pointer, it's not a structure. Always remember, in the moment I've written star a is not at all a structure variable, it's just a pointer. And what pointer do? Pointer can store the address of some other variable. What other variable? Here pointer can store the address of a structure variable. Which type of structure? Inventory structure. So that's why you can write a equal to address of s1. But suppose you have another variable here, integer x. Okay, do you think you can write a equal to address of x? No, because in that case, a is not an integer pointer. A is a pointer of this structure. So that's why it depends. You can only store a structure variable, address of structure variable in a. That's it. And remaining part is only, I'll say, suppose if you want to access a particular member of s1, then what we write? S1 dot number, right? This is how we access it. But if we want to access through this pointer, because if we see after this line, now a is pointing already s1, so there is a connection from a to s1, right? So previously what we did in our previous examples, that if we want to access the content of the variable which is pointing by this pointer, then we have to go for star a. If you remember, we have to go for star a, right? But here that's not the case. Here what you have to do, you have to use this symbol instead of dot. You have to use this symbol, and then you can use number. Then I think the number will print. The same thing is written here. See, if you use pointer, then you have to use this symbol instead of dot. Pointer name, pointer number, pointer price, then it will be printed. So this is the only difference. And or if you can also use, like, you can cast it like this, and then you can use dot. If you are not using this bracket and star, then you can go for arrow. This is the only difference. So read it from here, then you understand. But this point is important when we will discuss data structures. So when we'll start discussing data structure, without using this pointer to structure, nothing will be is possible. So you spend some time on this particular topic and write at least one program to understand this concept. Okay, then I think this chapter is done. There is some important points written here, troubles with pointers, that will be easily understandable for you. So study it by yourself and let me know if you have any doubts. So what I can say, that the chapter of pointer is already covered. I have discussed many concepts, but I try to make it simple, not complicated. There are we can make it a lot complicated, and there are a lot of additional concepts still there that I have not covered from pointer. What I try to do is I try to means follow the thing written in book. Since this is an online mode, so I'm making it a little bit simple and not explaining, I'm not going in more detail about pointer. What I'll advise you, that try to understand these basic concept of pointer, because what I have explained is the basics of pointer, and then try to follow the online other online details or all to understand it in more better way. Because pointer is not the end here, this is not the end of pointer, it's just the beginning of the concept of pointer. There are a lot more complicated things possible, but these complicated things will not I'm not considering them as a part of this course. As a part of this course, whatever I've explained is enough. So needless to mention you that you have to follow this example programs that I've given in this chapter. Okay, so I think this pointer is done. So next class, I'll start with this file management and see. This is a very interesting part and easy also, not like pointer. It's easy and interesting part called file management. So I'll cover it in one or two lectures and then I'll start data structures. Thank you for watching this video. Have a nice day.